Okay class, so now that we verified that the Pythagorean theorem formula is true, now we're going to use it to solve some of these problems, okay? So in this example, the problem is asking us to find the length of the hypotenuse. What is the hypotenuse? The longest side, C, right here. So we're finding this value. So, as the theorem states, a squared plus b squared equals c squared. Now, a and b can be kind of interchangeable. It doesn't necessarily matter. However, what does have to stay the same is the hypotenuse is always going to be c in this formula. Does that make sense to everyone? Okay, good. So for example, let's just have 4ba, so 4 squared, plus b squared, which is going to be 3 squared, equals c squared. Now, this morning with our review, we did squaring and square roots. You see how I kind of connected that there? Cool. So, can anyone tell me what 4 squared is, or 4 times 4? 16, right. 3 squared? 3 times 3? 9, awesome. And we'll still keep c squared. Now remember when we were solving equations, what is our goal? Isolate the variable, awesome, exactly. So we want to get c alone in this equation. But what is our first step going to be? Yes, we're going to be adding the 16 and the 9, so we get 25. 25 equal to c squared. Now we also worked on square what? So what is the inverse of squaring? Square rooting, exactly. So that's how we're going to get this value alone. We're going to square root using that inverse of the square. So we're going to square root 25, square root c. And that takes away our 2, so it's going to be equal to c. Now, what is the square root of 25? It's one of our perfect squares. 5, awesome guys. So the length of c is equal to 5. Is that making sense to everyone? We're kind of reviewing some of our old skills here. Okay, cool. So let's do another problem. In this equation, they're going to be asking us to find the length of the missing leg. So we have c. That is our longest side. We have the value of c. 16 here. And a here. So the missing leg that we're wanting to find is leg A, exactly. So again, we're going to be using the formula a squared plus, this is our b now, 16 squared. Everyone see what I did there? A squared, 16 squared, now it's going to be equal to 20 squared, exactly. A squared here, plus, can anyone tell me what 16 squared is? It's a little bit harder. 256, exactly. So 256 is equal to, all right, we have a little trick for doing these. 20 times 20, or 20 squared, what is that? 400, awesome. So we'll write 400 here. Now again, what is our first step when we're solving these equations? We want to isolate. Exactly. So, what is our first step? We're going to subtract 256 from 400. So, a squared is then equal to, did anyone find that answer yet? 144, awesome. Oh, does anybody recognize that number? Maybe? Okay, so now we're left with a squared equals 144. And then if we want to get this by ourselves, or by itself, what is the inverse of squaring? Square rooting. So we're going to square root both sides. Whatever you do to one side, you do to the other. So this is another one of our perfect squares. Can anyone tell me what a is? 12, awesome. 12. So does anyone understand how we're getting these? We're plugging in that formula to find the length of that missing leg. And this holds true to right triangles. Okay, so with your homework and your independent practice right now, I'll give you time to do it. We're going to be solving these equations. Now, there's going to be some word problems in there, but I know that we're really good at word problems, and what is the first thing we do? We want to see what it's asking, and then we break it down. So don't be intimidated by the word problems. Try to draw a picture as much as you can so you can visualize what it's asking. Okay, you can get started.